Hello children, today we will discuss Spearman's rank correlation. This is another way of finding out correlation between any two types of variables. Okay, now this rank correlation method, this was started by Spearman. It was developed by Charles Edward Spearman. This is the name of the statistician who started the concept of rank correlation in 1904. Since then we are following this method for finding out correlation. Now what is this method? It is an alternative to Karl Pearson's product moment method, right? It is an alternative to Karl Pearson's method which you have done earlier. Now why do we need to find out an alternative to his method? Though his method is also considered a very good method of finding out correlation. But why Spearman developed a different method and why there was a need to find out another method for finding out correlation? Because certain variables cannot be measured quantitatively. All variables cannot be measured in numbers. For example, if you want to know the variable beauty or honesty or intelligence between two variables, or you want to know the correlation between two variables which are qualitative variables like beauty, honesty, bravery, etc., then this qualitative data will not be able to, or with the help of qualitative data you will not be able to find out correlation with the help of Karl Pearson's method. Because Karl Pearson's method gives you quantitative measurement, not qualitative measurement, but Spearman's method gives you qualitative measurement between two types of variables. So relative expression of qualitative variables, that is beauty, honesty, bravery, etc., is given on the basis of their order of preference or ranking. That means qualitative variables are given, the relative expression of qualitative variables is given on the basis of their order of preference or ranking, right? So such variables which cannot be measured quantitatively, such variables are measured on the basis of ranking, right? So on the basis of ranking we give the measurement, or we find out the correlation between the two type of variables with the help of Spearman's rank correlation, right? Coefficient of correlation is calculated by rank differences. In this type of correlation, coefficient of correlation is calculated on the basis of rank differences. What do you mean by this? Suppose ranks are given to 5 participants and these ranks are given by 2 judges. Obviously the ranks will be different. It may not be the same. Maybe one person is allotted first rank by one judge and the same person may be allotted third rank by the another judge. So in this way ranks may be different, and on the basis of rank differences we find out what is the correlation of judgment of 2 judges, right? So on the basis of ranks given we find out the correlation between the judgment or between 2 variables. Okay, now we will see what are the uses of Spearman's rank correlation. First is computation is quicker, especially when number of items is small. Let me tell you one thing, that this method is more suitable when the number of observations is small. Normally if the number of observations are big or observations are quite large, then in that case this method cannot be used. So this way, first use is computation is quicker because this is a very simple method, easy to calculate. So computation is quicker, especially when number of items is small, right? This is one use of Spearman's rank correlation. Second, useful for series of data such as ranks, scores, etc. When the ranks are given, then this method is most useful. Or as I told you, in case of qualitative measurement or qualitative data, rank correlation method is very useful. Third use, it permits us to correlate two sets of qualitative observations which are subject to ranking. Two sets of qualitative observations which can be allotted rank. That means either rank is given or they are allotted rank by us. In both the cases, this type of correlation is very useful. In the case of data in which ranks can be given or scores can be given. Okay, now these are the uses. Now let us see how do we calculate Spearman's rank correlation. This is the formula for Spearman's rank correlation. RK, that is rank, is equal to 1 minus 6 sigma d square upon n cube minus n. This is the formula what you have to learn. Now let us see what it is. RK is coefficient of rank correlation. This symbol is for coefficient of rank correlation. R was only for correlation in the case of Kyle-Pearson's method. Here RK is coefficient of rank correlation. D is equal to rank differences. Here D indicates differences of rank. Rank 1 and rank 2, right? Series of X series is given R1, X and Y series is allotted R2. The difference between the two is D. So rank differences is indicated by letter D. D square is squares of rank differences. N is number of pairs of observations. What are the total number of pairs of observations? Pairs means two series. So pairs of observations, that is N. Now value of RK lies between +1 and -1. Here again the value of rank correlation is between +1 and -1. +1 shows direction of rank in the same. That means in the case of +1, direction of ranks given by two judges, the direction is the same. But if it is -1, it indicates that ranks are given in opposite direction, right? They are moving in opposite direction if R is equal to or RK is equal to -1. Okay, let us see the calculation here. Now in the case of calculation, there are three different situations. We will take all the three situations one by one. First is when ranks are given. There may be one situation when two judges have given the ranks to different participants, right? And order of giving rank may be different, but the ranks are given to participants. Second is when ranks are not given to participant, only the marks are given or the score is given. Then in that case we have to allot the rank. So one situation is ranks are given, another situation is when ranks are not given, right? Third is when, this is when values of the series are the same. Suppose the scores are given and maybe by chance two persons are given same score by the same judge. That means he is not able to decide which one should get more or which one should get less. Maybe 12 score is allotted to 2 participants, right? Or maybe 10 score is allotted to 2 participants. This may be in the case of second judge also. So if this type of situation arises, then how do we calculate correlation? This we are going to find out. Okay, we will take the first situation when ranks are given. Now here the example is, in a beauty competition, two judges gave following ranks to 10 participants, Judge X and Judge Y, right? Now Judge X has given ranks in the same order. First one was given first rank, second one second rank, third one third rank, fourth, fifth and sixth and so on, right? Judge Y has given 10th rank to the first one, 6th rank to the second one, 5th rank to the third one and so on. Now we have to find out what is the correlation of ranks given by two judges, right? Now solution here, the steps are these. First, find out difference between two sets of ranks, that is R1 minus R2, and name it as D. So we will find out R1 and R2 and the difference between the two, and we will name it as D. Second step is calculate square values to get sigma D square. After getting D, we have to make square of it, and that will give you D square. Total of that column will give you sigma D square. Find out RK by using formula. I gave you the formula here, and this is the formula again written here. Find out RK. Now here, these are the columns what you are supposed to make in order to find out the answer. Now participants, the number of participants here are 10. So you will write down 1, 2, 3, 4 till 10. This is the total number of participants, so that you come to know that what is N. N is equal to 10 here, right? Now R1 is the ranks given by Judge X and R2 ranks given by Judge Y. So you will copy down these ranks. First Judge X in the R1 column, Judge Y, copy down these ranks in the same order in the R2 column, right? Now next step is calculate D, that is R1 minus R2. This is R1, this is R2. 1 minus 10 is minus 9, 2 minus 6 is minus 4, 3 minus 5 is minus 2, 4 minus 4 is 0, 5 minus 7 is minus 2, 6 minus 9 is minus 3, 7 minus 8 is minus 1, 8 minus 2 is 6, 9 minus 1 is 8, 10 minus 3 is 7. So calculate D in this manner, that is R1 minus R2. Now what is the next step? Calculate D square. That means make the square of this. When you make square of this, it will become plus, because minus 9 into minus 9 is plus 81. Same way minus 4 into minus 4 is 16. So calculate this column by making square of individual values. Now you have to do the total of D square, that is sigma D square, and here it is 264, right? So in this way calculate N, total number of items, then R1 and R2, find out the difference between R1 and R2, that is R1 minus R2 is D. Find out the difference of individual values, write down this here, then make a square of D column, each individual value make a square of it, do the total and get sigma D square to apply the formula. Okay, now we will see the formula. RK is equal to 1 minus 6 sigma D square upon NQ minus N. 1 minus 6 into sigma d square, see the value here, 264. N is 10, number of observations, 10 cube minus 10. Simplify it, you get this value, and the answer is minus 0.6, right? Now this shows coefficient of correlation is high because it is more than 0.5. It is on the higher side, and two sets of judgments are opposite to each other because the answer is in minus 0.6. That means two sets of observations by two judges, or the ranks given by two judges, are moving in the opposite direction, not in the same direction, because the answer is in negative, right? So in this way, this shows the calculation of rank correlation when ranks are given to you. I think you have followed this method. Now we move to second one, that is when ranks are not given. Let us see how do we do the calculation in case ranks are not given by the judges, but only scores are given or marks are given. Now in this case, we have to adopt uniform procedure of giving ranks. When the scores are given, like here, marks given by two judges in the debate competition are X and Y. These are the marks given, not the ranks, right? There are 10 participants and the marks given are like this. You can see here, these are not the ranks, these are the marks, right? Now when the marks are given by two judges, then in that case, what you are supposed to do? You are supposed to allot the ranks, right? And then follow the same procedure as we have done in the case when ranks were given, right? So in this way, first now we have to adopt uniform procedure. Uniform procedure, what does it mean? It means that whatever procedure of allotting ranks you are following in the X series, follow the same procedure in the Y series. That means if you are giving first rank to the highest value, then in the Y series also give first rank to the highest value, right? And if you are giving first rank to the lowest value, then follow the same procedure in the Y series, right? So two procedures are there. First, highest rank to the lowest value, and second is lowest rank to the highest value. So two procedures are there. You can adopt any one, whichever you want, and I tell you the answer will never be different. Answer will be the same, right? So either adopt the first method or the second, but whatever procedure you are following, remember children that follow the same procedure for both type of observations or both the series. Now let us see here. Example, marks given by two judges in the debate competition are X and Y. These are the marks given. Now for calculation you have to make these columns. Copy down X data first, copy down Y data, and you have to allot R1 and R2 to these marks. Rank 1 and rank 2 you have to given R1 and R2, and D, which is R1 minus R2. This is D, and make a square of D, right? Now when we copy down the data, X gives you this data. Let us see how we have allotted the rank. Now here first rank is given to the lowest value. See the value, this is the lowest value, this is given first rank. Next is 10, right? This is second rank. Then 11 is given third rank. Then 12 is given fourth rank. 13 is given fifth rank. 14 is given sixth rank. Then after 14, 15 is given seventh rank. 16 is given 8th rank, then 17 is given 9th rank, and then 18 is given 10th rank. So in this way you keep on giving the rank, starting here we have started from lowest. We can start from the highest also, but in this example we have taken lowest value as first rank, and then find out the next higher value and keep on giving the ranks like this. You need not have to write down 1, 2, 3, 4 in the same order. It can be according to marks given here. So 9th is first, 10th is second, and 11th is third, like this. So keep on allotting the ranks. Now in the third column we have copied down the Y series in the same order. Here again the lowest value is given first rank because we followed the same pattern here. 2 is the lowest value in this series, 2 is given first rank. Let us see the second, third, 3 marks were given, right? Third is the lowest, second lowest value, this is second rank. Then third rank is given to 4, then fourth rank is given to 5, then 6 is given 5th rank, 7 is given 6th rank, and then next value 7 is given 6th rank, and then 9 is given 7th rank, 10 is given 8th rank, 12 is given 9th rank, and 15 is given 10th rank. Okay. Now for your understanding I will show you again how we have given the ranks. I will rub this and show you. Now lowest value here is 2, that is first rank. Okay. Second lowest is 3, that is second rank. Then after 3 we have 4, this is third. Then we have 5, this is fourth. Then we have 6, this will be 5. Then we have 7. Then we have after 7 we have 9, this will be 7. Then we have 10, this will be 8. Then 12, this will be 9, and this will be 10, right? So in this way you have to allot the ranks to each individual value. After allotting the ranks you have to find out D, that is R1 minus R2, 7 minus 10 is minus 3, 9 minus 9 is 0, 6 minus 3 is 3, like this. Take R1 minus R2, name it as D. Then make a square of this, minus 3 into minus 3 is 9, like this. Make a square of individual value, and in the end do the total, and here sigma D square is 86, right? Now n is 10 and sigma D square is 86. After getting these values, apply the formula. Formula is Rk is equal to 1 minus 6 sigma D square upon n cube minus n, right? Same formula. Apply the values. Here 6 into sigma D square is 86, write down 86, n is 10, so 10 cube minus 10. Simplify this and you get 0.48. Now this is the answer showing coefficient of rank correlation, and the answer is in positive 0.48, that means plus 0.48. So it shows positive correlation of moderate degree, neither very high nor very low. It is a positive correlation of moderate degree between the judgment of two judges for debate competition, right? So this is the example when ranks are not given, right? When ranks are not given, only marks or scores are given, you will allot the ranks as I did here and find out D and D square and apply the formula and get the answer, and analyze your answer by writing that whether it is positive or negative and to what extent or to what degree, right? So this way we calculate coefficient of correlation when ranks are not given. And third is when values of the series are the same. That means two judges have given same rank to two people or two participants. Then how do we calculate coefficient of correlation? Now children, we'll see the third situation when ranks are equal or values repeated. That means the ranks of maybe two people or two participants are equal, or the values are repeated, right? If the score is given or marks are given, they are repeated, or if the ranks are given, then same rank is given to two participants. So in that situation, we have different formula. This formula is different from the previous two situations in which you use the same formula, right? But in this case, when ranks are equal, this formula is to be used, right? So you have to learn this formula. Now we'll take the example and we'll see how on the basis of this formula we'll calculate coefficient of correlation, right? Okay. Now example, these are the marks in statistics and marks in economics. That means these are the marks given by teacher to different students. Here we have 8 number of students. Suppose 8 students have got marks in statistics given by teacher like this, and in economics marks of 8 students are stated here, right? Now we have to see what is the correlation between the marks of both the subjects, that is economics and statistics. Now solution. For solution, as we have to apply this formula, we'll make these columns. These columns are similar as you have done in the previous two situations. You have to calculate R1 and R2, and R1 minus R2 is what? That is D, and then you have to make D square and find out sigma D square. Okay. Now here in this case, marks of statistics, this is X series, and marks of economics like this, right? Now as the ranks are not given, these are the marks given, you are supposed to allot the ranks. Now let us see what are the ranks. Now here I have taken highest marks as first rank, okay? 28 is the highest figure in this, so first rank here. Then second highest is 20, second rank. Then third highest is 18, third rank, right? Fourth highest is 16, fourth rank. Then next is 15, fifth rank. Then next is 12, sixth rank, and then next is 10. As you move on here, then we find that the 10 is repeated here. That means 2 children have scored 10 marks, right? Now in this case, till 12 we have given 6th rank, okay? Now next is 7th rank, okay? Now when we move to 7th rank, then we find that 2 have got 7th rank in this case. Now what we will do? We will give 7.5 to both, and we will skip the 8th rank, okay? So nobody will get 7th rank, nobody will get 8th rank in this situation, and both the repeated marks or both the children will get 7.5, right? Neither 7 nor 8, 7.5. We will skip 8 because the total rank has to be the total number of participants or total number of students in this case. So 7th is given to the lowest mark, that is 10, 7.5 and 7.5. This is the repeated rank. Okay. Now let us move to marks in economics. Let us see whether here also we have repeated marks or not. Now the series or the data is given like this. Copy down the data here. Okay. Now you have to calculate R2 by giving ranks. How will you allot the ranks? We have taken highest as here, highest as first. So here we have to see which is the highest and give first to that highest marks. As I told you, follow the same procedure. Okay. So by following the same procedure, here again highest mark is given first rank, second highest is 16, second rank, third highest is 15, third rank, next is 14, fourth rank, then next is after 14, next highest is 12, and here again it is 12, 2 times it is 12, right? Then what will we do? We have allotted till 4. Now these two will get 5.5 and 5.5, right? They will not get 5th rank, they will not get 7th rank. Okay. So sorry, they will not get 5th rank and they will not get 6th rank. So 5.5 to both. This is 5.5, this is 5.5, and then next is 11 after 12, next highest mark are 11, so this will get 7, no 6th rank, right? Because 5.5 and 5.5 is given here, nobody is getting 5th rank as well as 6th rank. So next is 7th, and next mark, these are 10, this is 8. And remember, the last rank what you are given, that should be the total number of observations or total number of items. In this case we have 8, so the last rank should be 8, not more than that here. Okay. Here it is not 8 because 7.5 and 7.5 is there, nobody is getting 8. Okay. I think you have followed ranking here. This is repeated rank here and this is repeated. Okay. So in this way, when the ranks are repeated, when ranks are equal or values repeated, here the values are repeated and ranks are equal, that means both are falling in this equal rank, so we'll give the rank like this, and values are repeated, then ranks will be repeated here in this form. Okay. So this, I think you have followed this method of giving rank when the equal values are there. After this, next step is calculate D. What is D? As you know, D is R1 minus R2, right? So 5 minus 2 is 3, 7.5 minus 4 is 3.5, 2 minus 8 is minus 6, 1 minus 5.5 is minus 4.5, 6 minus 7 is minus 1, 7.5 minus 3 is 4.5, 4 minus 1 is 3, 3 minus 5.5 is minus 2.5. Right? Now what next? You have to make the square of D column, and when you make the square, minus will become plus, and multiply these figures by the same values, individual values, and then get the squares of this column. 3 into 3 is 9, 3.5 into 3.5 is 12.25, 6 into 6 is 36, like this. Make the square of each value. Okay. Now after this, you have to do the total of this D column, and this will be sigma d square, and the total here in this case is 114, right. So this way you have calculated the data, and now you are ready to put the values in the formula, okay, for getting the answer. Now after doing this calculation, we will write down the formula first, right. As I told you earlier also, always write down the formula and then go on calculating the values. Here Rk is equal to 1 minus 6 sigma d square plus 1 upon 12 m3 minus m plus 1 upon 12 m3 minus m, right, divided by n cube minus n. Now what does it show? 6 you will write down here, 1 minus 6 sigma d square. You have got the value sigma d square is 114. So write down 114 here plus 1 upon 12. Now what is m? How many times the value is repeated, right? How many times the particular value is repeated in the series, that is m. So here in our case, in the x series it is repeated twice. So 2 cube minus 2 plus 1 upon 12. In the y series also it is repeated twice, 2 into cube minus 2, put the bracket, right, upon n is number of observations, these are 8, 8 cube minus 8. Have you followed the values, or how to put the values in the formula? How many times the values are repeated in x series and in y series? You will write down here accordingly. M is the repeated, or how many times the repeated value are there, not exactly the value, the repeated figure, right. So that is 2 cube minus 2, 2 cube minus 2. Now when you simplify this, then you get this value. Further simplification, when you are doing the calculations, move step by step and you get this answer, minus 0.36. What does it show? Here it shows negative correlation, right. That means the correlation between the marks of statistics and marks of economics is negative. They are moving in the opposite direction. Maybe one child is getting more in economics, or maybe less in economics and more in statistics. So this way they are moving in the opposite direction, showing the negative correlation, okay. This explains the calculation of correlation in the case of repeated values. So all the three situations we have taken, these are when ranks are given, second is when ranks are not given, and third is when ranks are same or there are repeated values, okay. So after doing these calculations, let us see in general what are the merits and demerits of correlation. Now here the merits and demerits are written here. Merits first, easier than Pearson's method of correlation. Carl Pearson's method of correlation, that was, in comparing to this, that was little difficult because there was long calculation and you have to calculate mean and standard deviation to get the answer. But here there is no such calculation involved, simply ranks are given. If, then in that case simple calculation is there, take out d and d square, and if ranks are not given, it is very easy to give the ranks and find out d and d square, right. So in comparing to Carl Pearson's method, this method is comparatively easier, but the difference is that it cannot do the calculation in case of quantitative measures. It is only good for qualitative measures because preference of order is given or the ranks are given, but merit is that it is easier than Pearson's method of correlation. Second, very convenient when series give only order of preference and not the actual values of variables. That means it is very convenient when series give only order of preference. That means if the ranks are given only, order of preference is given in the form of ranks, then it is very easy to calculate coefficient of correlation, right? But if ranks are not given but marks are given or scores are given, not the actual values, if the actual values are given, then the only difference is that you have to allot the ranks. Even then, I must say that it is very easy. Third, superior method for qualitative distributions. This method is considered very superior for qualitative distribution and not the quantitative distribution. And qualitative distribution includes the attributes like beauty, honesty, intelligence, bravery, etc. Right? So for this correlation, rank correlation method is very superior. Now demerits cannot be used in case of group frequency distribution. That means in case of group data where the frequency is given, this method cannot be used. This is one of the demerit of Spearman's rank correlation. It is good in certain cases, but if the group data is given along with the frequency, then this method is not considered appropriate. Second, it can handle only a limited number of observations. That means if there are limited number of observations, not hundreds and 200s of observations, limited number of observations are there, then it is easy to calculate rank correlation. But if there are large number of observations in hundreds or 200s or in thousands, then it is not possible to allot them rank and do the calculation of coefficient of correlation by this method. So these are two main demerits of Spearman's rank correlation, but still it is considered to be a very good method for finding out the coefficient of correlation in case of qualitative values, right? So this way we have completed the chapter correlation, and in your assignment you have got many numericals. Do more and more practice, learn more and more the method, and you will enjoy doing it, and try to learn the formula properly so that there is no chance of error or mistake, and I am sure you will get full marks in statistics when you are doing all these calculations. Thank you very much.